Okay, while that goes, today, what is our practical? Today, our practical is about. Yesterday, we did the practical for what do you call maker. Yesterday, we did the practical where we directly found the what do you call velocity of sound. Neither we didn't draw a graph, we didn't draw anything. We just directly found the velocity of sound. Okay, neither. We directly found the velocity of sound. Yeah. Today we are going to be going through the what do you call practical where we draw the graph in order to find the velocity of sound. Okay. Same material, same apparatus. What is the say purpose? Purpose is to determine the velocity of sound and determine the indirect indirect. Is there any problem? No. But using this we can figure out something for indirect. අපි බලමු යම් පුළුවන් ද නැද්ද කියලා. හරිද? There's one more thing. In order to draw a graph, what should we have? We should have a varying x value. Neither. To vary x value, here we have length and what do you call it? Length and frequency. Those are the only two things that are varying. What can we vary? We can vary frequency. What is the reason? Frequency අපිට what do you call fixed amount තමයි තියෙන්නේ. ඒ කියන්නේ 256 න 256. අපිට length එක මාරු කරලා frequency එක මාරු කරන්න බෑ ඒක ඇටියට. Because we have 256 total එහෙම තමයි තියෙන්නේ. So we are going to be using tuning fork as our independent variable. Therefore, the dependent variable will be the length of the air column. හරිද? Next. When a closed tube. හරි. What is the theory here? What is the theory here? Anyhow, throughout this experiment, what can you observe? You're going to be using different set of what do you call? Different sets of tuning fork to get this wave pattern. You will be always using different set of tuning forks to primarily end up with this setup. Again, this wave pattern. Okay, we are only so yeah, we are not going to the second overtone. We are just staying, we are trying to find fundamental frequency for all the values. Okay. So when a closed tube resonates at the fundamental frequency, the relationship between the length of the air column and the end correction can be written as L plus E equals lambda divided by 4. What is this? This is 1/4 of the wavelength. N is lambda divided by 4 කියලා. Okay. Now, from this we have to subject lambda, so we get 4L plus E. Okay. We get 4L plus E. We get lambda equals V over F. How did we get that? We got it from V equals F lambda. V equals F lambda එකේ එහෙම ගන්න පුළුවන්. So, එයා හරි නම් we can write 4L plus E equals V divided by F. What are we trying to draw the equation for? We are trying to draw the equation for L versus F graph. L versus, yeah, the proportional between L and F. So, අපි ලියනවා 4 එක පල්ලෙහාට දාන්න පුළුවන්නේ. 4 එක මෙතනින් cross multiply කරන්න පුළුවන් මෙතනට. Then we have L equals V over 4 plus 1 over F minus E. Okay, නේද? Now using this, we can draw a y equals mx plus c graph. ඔන්න කැට කතාව මෙයා plus c නෙමෙයි minus c. හරිද? මෙයා minus c graph එකක්. අවුලක් නැහැනේ. by plotting L against the so at the end of the day, how are you going to find velocity? End of the day, velocity is going to be here. Gradient times 4 is equals to velocity. Okay, that's how we are going to find velocity. So let's see with all the equations, all the theories. Do you have any doubts? Otherwise, all the theories applied in the last experiment, yesterday's experiment, will apply here as well. Okay, neither. If you have no doubts, thumbs up එක දාන්න. Thumbs up එක දාන්න බලමු. දාන්නකෝ. Okay. Next, we have procedure. Next, we have procedure. Now, in this, we have to follow the normal procedure. What do we do? Immerse the tube completely into the water, vertically into the water, within the jar, leaving a small length of air corner. Then, we select the same principle as sonometer, but we are not going to use the largest frequency. Then, we are not going to use the smallest frequency first. අරකේ වගේ ලෙන්ත් එක ඇති වෙයිද කියලා බලන්න ඕනේ නැහැ කියලා මං කියනවා. බලන්න ඕනේද නැද්ද? Should we find or not? කියන්න බලමු. Whatever I said, is it true or false? You should, when you start the experiment, is it necessary? True or false විදිහට යන්නකෝ. When we start the experiment, we have to use the frequency with lowest okay, what were we doing? Hari. Yeah. When we start the experiment, we have to first choose the lowest frequency in order to find whether the tube is long enough to do the complete experiment. Is it true or false? It is true. Why? Because at the end of the day, if we are using the lowest frequency in tuning fork දිග වැඩි නම් එයාගේ L එක වැඩි. හරිද? L එක වැඩි වෙනකොට if the L is greater than 100, because you are using 100 centimeter tube or whatever tube you are using, then you can't do the experiment. You have to find a different tube. Next. So then we choose the highest frequency, that tuning fork with the highest frequency. Then we take that tube, what do you call, tuning fork, ring it, and then place it here. Okay? If you place it like this only, if the place is such that the prongs are vertical, then only all the energy will be transferred into the air in the tube. Okay, Nether? Next, what else? Slowly raise the tube until you hear a loud sound. Haridha, when you hear a loud sound, fundamentally you have reached the fundamental resonance. What do you do? Frequency 1 over L. The highest frequency is 512. 512. 1 over 512 and then what is length? Length is whatever you find here. Let's say 20 cm. Next. What is the relationship between frequency and length? L is proportional to 1 over F. So when frequency decreases, what will happen? Length increase. We are taking the next frequency. Next frequency. Next frequency again 456 to Makata. We are getting the next frequency as a next tuning fork and then doing the experiment again. When you start doing the experiment like that, what will happen? Length එක වැඩි වෙනවා. Length එක වැඩි වෙන්න fundamental, so the length of the fundamental tone will increase. Therefore, we can continue the experiment from here. Again, you don't have to drop it back down. You can take it from there, rise it up, and then find the next point where you get the loudest. Yeah, when you loudest sound. Okay, then you measure L2, and then මේ chart එක fill කරනවා. මේ fill කරගෙන යනවා. Okay, මේව fill කරගෙන යනවා. Then you have to fill it up to 60 readings, because why? We have 6 tuning forks. That is the reason, main reason. We have 6 tuning forks, you will get 6 readings. Then we will get a graph of L versus 1 over F. ඔන්න මේක අවුලක් තියෙනවා, මේක මේ පල්ලයට එනවා. Okay නේද? We can, using L and F, we can මේම graph එකක් එයි. මේම graph එකක් එනවා. Okay නේ? මේම graph එකක් එයි. මේ graph එකේ මේ මෙන්න මෙතන join වෙන එක තමයි E. Okay නේද? Do you have any doubts? You find the gradient, whatever this is, gradient is tan theta, and then gradient times 4, you will get velocity. Do you have any questions? Now here there's the issue. If you take it as centimeters, gradient times 4 is equals to velocity. Gradient times 4 divided into 100, because you have to turn centimeters into meters. So gradient times 4 divided into 100 will give you meters per second. Okay, that's done. You will get 3,560, 35,600 centimeters per second. Centimeters per second, and then you will be like, you forgot to divide by 100. Okay, Nathan? Do you have any doubts? Do you have any doubts? Next question. Next we have to go to procedure ivarai, make ivarai, gear bar make a same as last experiment. Distance me, yeah, almost everything. The only difference between this and that is there you have the equation. There you have the equation. What is the equation? V equals 2F L2 minus L1 kilo. You directly find L2 and L1, add it into the maker, and directly get the substituted value. There is no graph. Okay, there is no graph. Method, you are getting this equation. Therefore, you have to draw a graph of L versus 1 over F in order to get the velocity of sound. Which one is more accurate? Which one is more accurate? This experiment is more accurate. Okay, Nick? This experiment is more accurate. Next. Okay, now we'll go for the special points. Before starting, we have to check whether the tube is long enough. Therefore, we use a lower frequency tuning fork first and check whether you hear a loud sound for it. Okay, when you raise the tube. If you have raised the tube completely and still you haven't heard the loud sound, then you cannot do the experiment. You have to find a large jar and a larger tube. Or else, next, always start the experiment with high frequency tuning fork. This will give you the shortest length. Again, when you start the experiment, you have to find from the lowest length, lowest frequency height. You can't go to the maximum height and then try to drop it off. It is really difficult. So what you do is you take the really short length, okay, and then use the shortest prong. Tuning fork with the shortest prong, you can highest frequency, and then slowly raise it, and then you will find the answer, and you will find a pattern. When you find the pattern of, you will directly be able to find may well like first frequency guys, second frequency guys, first two tuning forks guys, you can assume a pattern. ඒක අහන්න when you're if you're doing it in real life, what you do is you assume a pattern. හරි මේ වගේ pattern එකක් එන්න ඕනේ කියලා හිතලා then you can do for you can easily find for rest of them as well. හරිද ඒක අහන්න ඒක අහුවත් ලියන්නත් එපා. And how do you find it? You slowly raise from the earlier position and then move it until you hear the loudest sound. Okay, next. We have to use a tall water container to allow the resonance tube to completely submerge. And then when it is completely submerged, the water level should be somewhere here. When you take the what do you call tube out, when you take the resonance tube out, मैं ගිල ඔන්න 100 centimeters වල මෙතනට බහින්නේ නැහැ. සාමාන්‍ය මෙතන it will drop out to somewhere here. අන්තිම වෙනකම් බහින්නේ නැහැ. හරිද? Because it doesn't take that much volume. We have to use sand or cotton stripping at the bottom of this in order to reduce the what do you call to prevent the unwanted sound waves to getting reflected off the base and disturbing the fundamental resonance. Next, we cannot use volatile liquids. Why can't we use a volatile liquid? Alcohol, acetone, petrol, diesel. What will they do? They will decrease the density of this liquid by density of the air by saturating the air with the liquid. Okay, නේද? Therefore, එයා හරියන්නේ නැහැ. What else? If they ask, මෙහෙම, if they ask, if they ask, what is the velocity of sound in air when it is saturated with alcohol කියලා? එවනම් alcohol දාලම කරන්න. හරිද? If they ask when it is saturated with water, water දාලා කරනවා. If it is saturated with diesel එහෙම මොකක් හරි කිව්වනම් diesel වලින් තමයි fill කරන්නේ. එතකොට මෙයා automatically saturate වෙනවා. Okay නේද? Yeah, that is also a thing. Next, keep track of the room temperature. The calculated velocity is what do you call atmospheric specific to atmospheric temperature and pressure. So ultimately you are gonna choose the temperature. Temperature කියන්නේ 27 Celsius කියලා ලියා ගන්නවා. Pressure එක 1.1 bar කියලා හරි මොකක් හරි ලියා ගන්නවා. barometer එක බලලා thereafter උත්තරය යනවා. උත්තරය ආපු ගමන් මෙයාට තමයි මේ value එක කියලා හිතා ගන්නවා. හිතාගෙන as I said earlier, sometimes you with the in labs you have the book where මේ celsius එකටයි මේ pressure එකටයි තියෙන velocity ගණන කියලා. Okay නේද? So you use that and check whether your accurate measurement is correct or not. හරිද? What else? As I said yesterday as well, every person has their own frequency range and own loudness range and pitch range. Therefore, the same person should continue to do the experiment. If not, experiment එක කෙලව ගන්නවා. Can someone say the speed of sound in air? නිකන් කියන්න බලමු. Speed of sound in air. Speed of sound in air. කවුරු දාන්න chat එකට දැන් තමයි පළවෙනි පාට chat එක අහන්නේ. දාන්න බලමු. අපිට කියලා දීලා තියෙන්නේ මොකද්ද? at least ඒක හරි කියන්නකෝ. Can you tell something? අපිට දන්නවා anyhow velocity is 3. 3 කියලා පටන් ගන්නවා. හරිද? ඊට පස්සේ 4 or 5. 4ද 5ද? තව දාන්නේ මෙතන. 4ද 5ද? 4. හරිද? ඊට පස්සේ එන්නේ 3. 3 4 3 3 4 3. හරිද? 3 4 3.3 කියලාත් එනවා. ඕනේ නම් at I mean this is at 20, okay? I guess at 40 or something. Not at 40. 33 වගේ you get 350, okay? At 33 වගේ you get 350. ඔන්න මේක දාලා ගාන හදන්න කියලා ප්‍රශ්න තිබුණා. 350 directly. 350 කියන්නේ somewhere around this temperature, not exact temperature. I'm saying somewhere around this. And this also. 340 කියලා දීලා තිබුණා. 340 කියන්නේ around 20 වලට අඩු වෙන්න වෙයි. තුනක් අඩුයි. තුනක් කියන්නේ 15 15 Celsius වගේ. Just another knowledge, extra knowledge. So anyhow, so මේ වගේ තමයි temperature එන්නේ. So if you normally our temperature is 20 නේ 27 කියන්නේ 27 වලට ඉන්නේ around 346 or 7 346 347 කියලා තමයි ඉන්නේ. හරිද? එහෙමනම් at 27 Celsius 346 එනවා. 346 ආවම ආවත් හරි. උත්තරේ ආවත් හරි. 346 සමාන they will normally මේක ඇතුළේ තමයි උත්තරේ එන විදිහට හදලා තියෙන්නේ. Sometimes you get 356 as well. ඒක කරන්න දෙයක් නෑ. But normally the answers are somewhere around here. Okay නේ? Please be mindful of that. ඒකට graph එක ගන්න දාලා when you get an answer, if your answer is something like 360, වැරදි. Something like 320, ඒකත් වැරදි. Okay නේ? වැරදි කියලා හිතාගෙන try to do the question again. හරිද? If you do the question 3 times, 3 or 2 times and still get the same answer, එහෙම නම් කරන්න දෙයක් නෑ. What they have done is they have made the answer so that it is confusing. Okay නේද? 9:30. 9:30. Let's go start the what do you call makeup. තව how many dates? We have 38 days more for biology. 38 days more for biology and maths. What about physics? 38 plus 4. 38 plus 4, you have 42 days. Out of that 42 days, you can 42 days එකකින් 10ක් අඩු කරගන්න because you won't touch physics නේ. biology පාඩම් කරනවා, biology exam වලට prepare වෙනවා, අරව මේවා. ඒ නිසා දවස් දෙකක් බලන්නේ physics. So you have only 32 days left for physics. ඕන දෙයක් improve වෙනවා නම් you have only 32 days. ඒ 32 days එකේ I'll take another 13 hours. That's not much. There are enough and students, enough and more students. I know. When I did A level, 5 නිදාගන්න නැතුව මේ ප්‍රශ්න හදලා improve වෙච්ච ළමයිනුත් ඉන්නවා. improve වෙච්ච ළමයි නම් yeah. improve වෙච්ච කෙනා හොඳ result ගත්තා. where were we? Yeah. So, to study the resonance phenomenon in sound, you are asked to use a glass tube with a piston and a set of tuning forks A, B, C, D, E found in your laboratory. the piston can move smoothly inside the glass tube. Then what they have done? Can someone explain what they have done? What they have done is, now this is the resonance tube. මේ ජාරක මෙහෙම අයින් කරලා. ඕකේනේ? මේ ජාරක මෙහෙම අයින් කරලා. මේ ජාරක මෙහෙම අයින් කරලා. Okay? And there's no water inside. Okay? And then what they have done? Make a tube bigger, make a tube bigger, make a tube bigger. The tube. හරිද? මේකට මෙතන piston එකක් දාලා. හරිද? So what is going to happen? This part of the resonance tube will act as the, what do you call it? One enclosed resonance tube. One in එක පැත්තක් වහපු resonance tube එක. The one enclosed resonance tube. Okay? Then we have all the sorts of what do you call frequencies. As you can see, it says 256, 384, 84. Yes. 512, 420, 320. Now, what is the frequency of tuning fork B? What do you do? A is the shortest, so එයාට දාන්න. හරිද? ඊට පස්සේ B is the next shortest. හරිද? C, D, E. Okay නේද? A ලොකු මේකයි, E පොඩි මේකයි. Oh no. Yeah. Frequencies. Yeah. Because the tuning fork with the longest prong will take the lowest frequency. Okay neither? For a given tuning fork, briefly describe how would you obtain a resonance with L note corresponding to the fundamental tone. What do you do? For a given tuning fork, briefly describe how you would obtain a resonance with L note corresponding to the fundamental note. How do you take it? Sound the tuning fork and place it close to the open end of the open end of the tube and move the piston slowly. Make to the right. Make a left. Make a right. Make a left. Make a right. So slowly to the right. What will happen then? Length of the what do you call arc column of fundamental tone will increase. Length increase when at a certain point sound will gradually start to increase, become maximum loudness, and then start to decrease. Find the maximum loudness and do the makeup. Next, state whether you would start the experiment with the tuning fork having the highest frequency or with the tuning fork having the lowest frequency. First, give the reason. කවුරු කියන්න බලමු. කවුරු කියන්න බලමු. We use the tuning fork with the highest frequency. Neither. Because what is the question phrased as? Yes, what is the question phrased as? How would you start the experiment කියලා? How would you start the practical කියලා වුණා? Lowest frequency, because you have to check whether the tube can perform the whole experiment or not. Now, instead of the ear, a sound measuring instrument is kept close to the open end of the tube to record intensity level of sound when L is varying in order to obtain L note. Sketch below expected variation of phase with L. X with L කියන කොහොම ඉන්නේ? මෙයාවත් මකමු. මෙයාව මකමු. We don't need this නේ. We have S, we have L. We have 1, 2, 3, 4, 5. Anyhow, at L, you will get L එකේ as I said, gradually increase, then decrease. නේද? එතන මේ increment point එකේ L note එකේ තියෙනවා. Next. මේකේ කවුරුත් නැහැ. මේකේ කවුරුත් ඉන්න විදියක් නැහැ. ඊට පස්සේ මෙයා මේකේ මේ කෙනෙක් හැදෙනවා. Slowly increase, maximize and then decrease. Okay නේද? ඕනේ නේ 5 එකකට මේම ඇදගන්න පුළුවන්. There's also another clear pattern. What has happened to the loudness? When you change the frequency, loudness has decreased. What is the reason? We are using a longer tube, therefore a lot of energy is needed to, what do you call? Create the sound. Or no, but to achieve the resonance. A lot of energy is needed. Have a tuning fork is in the energy almost same across the palette. Any sa may energy bunata with the same energy if you take another tuning fork and ring it and keep it on top of it. Length therefore the energy needed to vibrate all the economy is greater. Any sa sound එක එන එක මදි වෙනවා. අඩු වෙනවා. Okay නේ? What is the corresponding resonance range for the first overtone in terms of L note? 3 L note. නේද? L note ඊට පස්සේ 3 L note නේ. 2 එක ඉන්නේ in resonance tube. How do we get? Resonance tube එකේ මෙහෙමනේ ඉන්නේ. මේකට පස්සේ ඉන්නේ මෙයා. මේම ඇවිල්ලා ඊට පස්සේ මේම ඇවිල්ලා මේම ඉන්නේ කෙනෙක්. එතන තියෙන 1 2 3 waves. I mean 3 segments. So 3 or 4 කියලා තමයි ඉන්නේ. හරිද? second overtone එකේ 1 2 3. So 1 1 2 3 4 5 segments. ඉතින් 5 or 4 කියලා ඉන්නේ. Odd numbers වලින් තමයි පණින්නේ 4 overtones. Okay නේද? Yes, I feel you are okay with that. Suppose now you wish to find density of sound in air using all the tuning forks in the above set. In order to use the graphical method, to find the velocity of sound in air, which tuning fork from the above set is desirable to use first? Only. Now, depending on the question, the answer changes. Like method, this is a 2003 paper. Here you get the highest frequency. Would our calling question eකට අපි lowest frequency කියලා. Why? Yeah, because they are starting the experiment by checking whether the tuning fork can handle it or not. මෙතන තමයි highest frequency කියලා උත්තරේ එන්නේ. Next. There's another important physical quantity that you should record during the experiment in order to report your recent results meaningfully. What is this physical quantity? Temperature. In B2 කියන්නේ CD කියන එක. It was observed that the value of S for 1 instant was 60 decibels. Find the corresponding intensity of sound given that the threshold of audibility is 10 to the power minus 12. කවුරු හරි 10 to the power what කියලා දාන්න බලමු. 10 to the power find x. x එක දෙන්න බලමු. ඒක ලේසි ප්‍රශ්නයක්. I want to see මේ theory දන්නවද කියලා. Because that's a theory question and not practical question. දාන්න. දාන්න කවුරු නැද්ද අද? උත්තර කියන කට්ටිය නෑ. එහෙමද? What is h going to be? 10 to the power minus 6. හරිද? 10 to the power minus 6. So that is the answer here. Okay. That is the 2003 question. Now let's go to 2011. When a tuning fork is at resonance with a tube with one end closed, what is the type of the wave being produced in the tube? Already clear, bro? Longitudinal or transverse? Standing or traveling? මොකද්ද උත්තරේ? 2011. Longitudinal standing wave. Longitudinal standing wave. දෙකනම නිවන්න marks. You are provided with a set of tuning forks of frequency 288, 320, 360, 380. A suitable glass tube, glass jar, and the other necessary items to determine the speed of sound in air using a graphical method. What is the purpose of immersing the tube in water? What is the purpose of immersing the tube in water? කියන්න බලමු කවුරු හරි? To produce a closed end with variable length. To produce a closed end with variable length. Thereafter, inside the tube showed in the diagram, draw the wave pattern of the mode of the vibration that you would set up for taking the data clearly. Indicate the incorrection and length. කොහොමද ගන්න? මෙයා incorrection same thing. මෙයා length. මෙතන වතුර තියෙන්නේ. And then there's the indicator. Indicator එකේ water level එකට you have to mark it and call it as length. Okay නේද? අහලා නැහැ but better to write draw that as well. Which tuning fork would you select first to take data? To take data. To take data නම් මොකක්ද දෙන්න ඕනේ? Tuning fork of highest frequency. Reason the resonance length is lowest for the tuning fork with highest frequency. Therefore, the fundamental resonance will be reached at the shortest length. Next, calculate the minimum length of the glass tube required to take data using the given set of tuning forks. Take the value of V in air as 345.6. අන්න දීලා තියෙනවා answer විශේෂ මේ range එක range එකක් දුන්නානේ ඒ range එක විතරයි තමයි ඉන්නේ කියලා. So we are 345.6 here. Well then, how do we do it? V equals F lambda. V equals F lambda. අපිට lambda දන්නවද? නෑ. plus C නේ දන්නේ. L plus C එක දන්නේ. I don't know whether we need. No, they are asking for minimum length. So what we have to do? Make minimum gum. Let's ignore E because may E එක හිටියා කියලා වැඩක් නැහැ. නේද? Even if the E is there, what will happen? L ගේ value එක අඩු වෙන එක තමයි වෙන්නේ. So when the E is not there, we'll get a value which is greater than what we need. ඒ නිසා කිලින්ම මේව දාන්න පුළුවන්. Lambda is equals to 4L. Lambda is equals to 4L. So we can write V equals L is equals to V divided by 4F. Velocity is 345.6. 4 times අපිට තියෙන්නේ 288. නේද? අඩුම එක්කෙනා 288. අඩුම එක්කෙනා 288. So what will be our answer? Then we have to find a tube which is greater than that. නේද? 30 centimeters වලට වැඩි tube එකක් හොයන්න ඕනේ. Okay, what is next? Obtain the necessary equation in terms of F and the resonance length L to determine V and E by plotting the graph. මෙයාම ගත්තා නම් හරි. මෙයාම ගත්තා නම් හරි. Next, they have given you 1 over F values. They have given you all the 1 over F values. And they have asked you to use another tuning fork in addition to the tuning fork given in the above to do the experiment. Which one out of the given set below you would select considering the requirements? We have the 288, 320, 362, කවද 480. හරිද? For these, one of F values are as මොකක්ද? මෙයාට දීලා තියෙන්නේ 3.5, 320 වලට 3.1, 362 වලට 2.8, 480 වලට 2.1. හරිද? Now what is the difference here? 4. Difference here almost 4, 3 කියලා දාගමු. හරිද? Difference is 3. මෙතන difference is 7. එහෙනම් මෙතන මැද එකනේ දාගන්න ඕනේ නේද? ඒක නේද ලේසි. ඒකෙත් we have two choices, 2.5 or 2.3. Which one is easier? Which one is easier? Okay, wait. Even it's now okay. Now is it lagging? No need. And 2.3 ගන්න. I'll tell you the reason. හරිද? Check the gap between the two. 1 over F values. 2.8 minus 2.3 will give 5.5. 0.5. 2.3 minus 2.1 will give you 0.2. It's not balanced neither. ඒ වගේ 2.5 ගන්න බලමු. මේ පැත්තට 0.3, මේ පැත්තට 0.4. Almost balanced. So we have to use 2.5 as the value. So 406.4 තමයි answer. Okay නේද? Next. Draw a rough sketch of the graph you would expect. ඒක මතකයි නේද? මේ එකක් ආවේ graph එකක්. If the room temperature was uniformly increasing during the period of taking data, draw the curve. என்ன வேணும் மக்கும்னே? This is a 1 over F versus L graph you're going to get. Now they are asking if the temperature increases, what would happen? If the temperature increases, what would happen? මේවා velocity එක වැඩි වෙනවා. Because why? Velocity is proportional to temperature. මිස්සක් නෙමෙයි. සාමාන්‍ය මේව mark කරා නම් you will get marks. Okay නේද? Reason? Velocity is proportional to temperature. Okay නේද? So, එච්චරයි නේද? Do we have any other doubts? If you have no doubts, අද නවත්තන්න පුළුවන්. Is the explanation clear to you? If it is clear, may heart reaction එක දාන්න බලමු. Okay. අද කට්ටිය අඩු වෙලායි. කමක් නැහැ. හිටපු කට්ටිය නැති වෙලා. So, yeah. Then let's end the session for today.